Yeah, welcome everybody. I'm Marton Elek, and I would like to speak about the connection between Hadoop, Ozone, and Kubernetes. And, oh, yeah, I can do it. I'm an Apache committer in the Kbernetes project, which is an incubator project. And this is a Raft protocol implementation which could be embedded to somewhere. For example, it's embedded in a new subproject of Hadoop. This is the Hadoop Ozone or Hadoop HDFS. I also have some playground project where I'm trying to containerize the whole world. I started it with the Apache big data projects, and I'm running them in multiple environments with HashiCorp Nomad, Kubernetes, Docker Swarm, Docker Compose, and in a different way. Okay. But I would like to speak about the Kubernetes and Hadoop and the connection between them. And this is not just a one-way connection. So it's not just about running Hadoop in the Kubernetes, but what I believe that the opposite direction is also very useful. Hadoop is a storage system, right? And at least the HDFS part is a storage. And I think storage is a very valuable component in the Kubernetes ecosystem. So this is what I would like to speak about. But first of all, we need to clarify why do we need to check Kubernetes at all? So why could be it interesting? We know that the Kubernetes is the new unicorn and it's in the top of the hype. So why we would like to start Hadoop there? Well, we need to check the Kubernetes and what kind of components are run usually in Kubernetes. And I think we can agree that one of the reasons of the popularity of the Kubernetes is that it's a very powerful way to run microservice-based application. And the microservice-based applications are run very well. So the next question, what are the microservices? So what is this architecture? Well, it's very good, but there is no exact definition, but I just got one from Martin. And according to this definition, the microservice is something like where we have small services, own processes, and lightweight communication. So small service, own process, lightweight communication. Small service, own process, lightweight communication. This is a Hadoop cluster with all of the components, and what can we see? Own processes, lightweight communication, and more or less small services. It depends from the distance where you check it from. So it seems that the Hadoop and the Kubernetes and the microservices, it's a very good pair. And the Hadoop and the microservice is almost, at least it's similar. So so my guess that it should be useful to check them, because my expectation is that also could be useful for Hadoop if it's very similar to the microservices. So we need at least to check it, and this is why we are here, to check how the Hadoop could be run in Kubernetes. But first of all, what is Apache Hadoop? Do you use Hadoop? Or do you know? Oh, very good. I have a complete Hadoop training just in 60 seconds. So what is Hadoop? This is exactly the same way as I explained Hadoop to my grandparents, that what I'm working on every day. So it's a complete training, actually. So Hadoop is a big data tool set, actually. So next question from my grandmother, that what is big data? Yeah, this is exactly the same as the small data, just bigger, right? So what is the small data? Yeah, that's an easy question. The small data is an Excel sheet, right? I'm pretty sure that small data equals an Excel sheet. So big data is an Excel sheet which can't fit on my computer, right? That's in the picture. So how can I do calculation with this? Well, first I need a lot of machines, and I need to split or cut the Excel sheet to smaller parts. And one of the Hadoop subproject, the HDFS, is just splitting the data and replicate them and handling all of that. This is one problem. The other problem is that now the calculation is a little bit more difficult. For example, if you would like to calculate the maximum number in this Excel sheet or in this data set, you need to calculate the maximum at each split. And after that, you need to calculate the maximum or the maximum. So this calculation is handled by Yarn, which is a scheduler, and it could just execute all of the calculation in the right place. And we also have the MapReduce, which is a library to write this calculation. This is not the only one which could be used, although other frameworks or products such as Spark or Flink could be used. Oh, was it 60 minutes or 60 seconds? Oh, maybe. But there is a new component in Hadoop, the Ozone, and actually two new components, Ozone and HDDS, which are merged just 2 or 3 months ago. So the next question, what is Apache Hadoop Ozone or HDDS? Well, for understand that one, we need to understand first what is the HDFS. Okay, so for Hadoop HDFS, as we discussed, we have the big data, and we just splitting them and trying to distribute them on the data nodes. We have one master node or two master node, a name node, and we have worker nodes. So there are two main responsibilities of the name node. One is just a map between an ID and the location of the data. So this is an ID of a big binary data, so a byte array or something like this. And we have a map, and if you say that this is the first block, then it should be replicated to somewhere, ideally on multiple machines. And there is another map where we map a file to multiple block IDs. One or multiple block IDs. It depends the size of the file. Usually we are just splitting the file and replicating the block. So this is the name node. This is in the name node currently. And I think it's very well known that there are some limitations here because both of the maps are handled in the same component. So the idea is just we need to cut them, to separate them to two separated components. And the bottom one is the Hadoop HDDS. This is one of the new sub-projects. And the idea is that we need some very low-level service just to replicate binary data. It doesn't matter if it's a file data or an object or something, just the binary data in a block should be replicated. And top of it, it's very easy to implement additional services like a file service. As in the HDFS, but it's easier to start with some even more simple service, like object store. It's very similar to the S3 object store. We have buckets and no files, just keys. So this is the Hadoop Ozone. This is another new sub-project, and Ozone uses the HDDS lower level layer. In fact, it's not just a separation, but there are some other optimization, because until now we had a problem with the many small files in HDFS. I don't know if you know it, but the problem is that if there are many small files, all of the data nodes are reporting just the block IDs that, oh, I have it, oh, I have it. So the idea is that we can report it in bigger groups that, oh, I have this group of blocks. So we can use just this super block mapping, and we can use this super block here. Okay, so we can implement very easily an object store like S3, but this is not the only one what we can implement, because we have the lower layer, so everything is possible. We have the object store, we can implement another mapping to map something from file path to a binary. So this is the HDFS, it also could be refactored. We can provide more low-level raw devices. This is the Quadro sub-project. It's still on a feature branch. And long-term, I'm not very familiar with Hive and HBase, but long-term, I think they also could be improved to use just the lower layer instead of the fiber, because usually Hive doesn't need any file, just a binary which is replicated. Okay, this is the Apache Ozone and HDDS. So let's go forward to the Docker. So next question: how can we Dockerize, or how can we containerize it? Well, it's easy. I don't know. Is it familiar for you, this creating Docker file? So this is just the base image. I'm putting the Hadoop and done. Yeah? My original title for this presentation was how to containerize Hadoop, but I realized just it one slide. So done. Nothing else. So that's not the tricky part. So what is the tricky part? Yesterday I had another presentation about the tricky parts, and my statement was that, you know this, This is every household appliance is tagged in the European Union, just to make it easier to compare. And yesterday, I said that we need something similar for all of the containerized environments as well, just to make it easier to compare if Kubernetes is good enough or not. So I have some label for Kubernetes and all of that. And so the tricky part is not the containerization. The tricky part is the configuration management, the provisioning to provide some kind of networks between the containers, the multi-tenancy. So there are a lot of problems that should be solved with the containers. But today, we won't check all of the technical details. Instead of that, we will check from the user point of view. So we have a Hadoop issue where there are some design documents, and we have two main use cases, one for the developers, one for the users. Are there any developers here? Okay. Users? Okay. So what is more interesting for you? Oh, I have both, so or we can just try it out, and after that I can. Okay, so let's start with maybe with the user part. So that's a Hadoop documentation. I don't know if you know there is a new feature, that router-based federation in Hadoop 3, and this is actually just one part of the documentation. So if you are interested about the router-based federation, it's easy, very easy. You need just read 10 pages of the documentation, check all of the properties, and try to find the right properties. And it's especially complex because router-based federation works between two HA Hadoop clusters. So the only thing what you need is just create one cluster and other cluster. Both of them have two name nodes, data nodes, journal nodes, router. So it seems to be complex, right? What about if somebody just interested about what is this router-based federation? And my vision is that we need to provide Docker Compose files. And actually this is, can I? Oh, okay. So this is in my project, but some of the stable features are already sent to the Apache. So my vision is that we need to provide some kind of Docker Compose file to with every new features. For example, this is the erasure coding, and by default, it's easy to start a Docker cluster. So you don't need to understand, but you can see that it's almost the same thing, just repeating for all of the components. We have an image, we have some startup scripts, and we have all of the configuration as environment variables here with some naming conventions to save it. But my idea is that it shouldn't be understood. You can just use it as a Docker Compose definition, and you can start a local cluster, and you can play it, and you can try it out with just Docker Compose up, and you have a local cluster. Even with this this cluster could be. Where is my cluster? So this cluster could be started in my machine. So it's 24 components, and it's very, very hard to do a real cluster. But with this Dockerized approach, it's very easy to start. Okay, let's go back to the full screen. Okay, so that was the user-based approach, but the same is true for the development. Maybe are not involved on the development, even if I strongly recommend that it's a very good part. But we have similar definition of the clusters with Docker, and we can just try it out very fast, every new patch. And after that, it's faster to apply the patches. And I have another vision that that there are votes before the Hadoop releases, and usually the committers are just checking out and doing some smoke tests. So all of the new Hadoop releases are very stable, and all of the new Hadoop versions could very stable calculate the word counts usually and the terasort, because these are the features which usually are tested. And my idea is that we can, with this Docker Compose-based approach, we don't need many machines, but we can just test it locally and start. cluster, and the whole Hadoop could be more stable. Okay, so that's just the technical details. That the two approach. One is the development. We don't need anything in the Docker container. We can just map the latest build version and acceptance test and check the version. And the other one is just to provide easy-to-use environment for the end users. Okay, so that's the power of the containerization, I think. So even just locally, it could be very useful. Let's back to here. So what's next? It's very good, but there is one problem with that, that it could work only my machine. So the idea is that I would like to use the power of the containerization in a cluster. So what can I do? Yeah, Kubernetes is the new unicorn, so I would like to try it out. We already discussed why it could be a good idea. So next question, do you know Kubernetes? Okay, more or less. I have a 60 seconds complete Kubernetes training, so never mind if you don't know. But sorry if I just oversimplify something. So the problem was that I have multiple nodes, right? I couldn't use the Docker Compose-based approach when I can just start more and more containers on my local machine. So I need something. And the Kubernetes, first of all, it's a scheduler. So I can just say that, oh, I need a container, please start it somewhere. And I'm not interested in where the containers will be started. They will be started by the Kubernetes, or another two containers, another application, or a third one. And the big benefit of the Kubernetes, comparing, for example, to the Nomad scheduler, that it's not just a scheduler, and it could handle together the containers as applications. So it could provide additional features like network, storage. For example, the same config files could be magically mounted to the containers without any other thing, or there will be a virtual network between the containers. Okay, and all of the complexity of the Kubernetes, so the resources, the resource definition, are just, most of them are just definitions or rules that how the containers should be executed. For example, the daemon set is a rule to start a container instance on each node, or the replica set is just a rule to start a given amount of containers somewhere, doesn't matter where. Oh, so it seems to be very powerful. So what's wrong with the Kubernetes? Well, it's nothing is wrong, but the problem is that the way how the Kubernetes is thinking is a little bit different than how the Hadoop thinks. Imagine a backend application. So this is a backend application, and the Kubernetes could scale it up, so it could start multiple backend. And I have a front-end application. And the front-end application, it's very dumb. It would like to just connect to the backend. But now I have multiple backend. So Kubernetes provides a load balancer. And it balances all of the incoming requests to one of the backends. Well, it seems to be OK. There is only one problem, that those containers have no network identity, no DNS, nothing. Only the Kubernetes service, the load balancer itself, has network identity. And what do we need for Hadoop and typically for any other stateful distributed application? We need network identity because we have already solved the same distribution or replication problem. And for the replication, we need to communicate between data node and name node, or between the client and the data node. So we need stable network identity, stable DNS, which is not available except for the stateful set in Kubernetes. So the stateful set is the most common way to run Hadoop and similar distributed application. And yeah, it could be used, and it's very useful. But for example, stateful set, you can't do easily the same what you can do with a daemon set. For example, to start a worker node at each physical node. OK, so it seems to be working, but what are the benefits to run Hadoop? Well, we can say a lot of things about Kubernetes, but there are my two favorite ones, the ecosystem and the flexibility. So let's check an example. Okay, to monitor Hadoop with Prometheus. Do you use Prometheus? Okay, it's a monitoring tool, something like this. So monitoring tool, you have a lot of data, and it just can display it, and you can calculate a lot of things. So it's very easy. By default, there is a Prometheus server, and it polls the other components, and there should be an HTTP endpoint here, which prints out all of the metrics. So that's what we need. Okay, yeah, but what we have is just a good old Hadoop application. There is no HTTP endpoint, and the other problem is that Prometheus doesn't know where are the HTTP endpoints. So, what was the two benefits? The flexibility and ecosystem. So the ecosystem part is that nowadays I think nobody can introduce a new development tool without Git support, right? Because the Git is just so widely used. And I think sooner or later, but rather sooner, that will be the same situation for Kubernetes. So just newer and newer components are supporting Kubernetes. Prometheus is also under the Cloud Native Foundation, so it's very easy. But Prometheus supports Kubernetes, and it's very easy. So it can just check the Kubernetes API and collect all of the available HTTP endpoint. And yeah, this is a Kubernetes resource definition. You don't need to understand. You need just to check the difference. So where is the one difference? Yeah. So all the thing what we need is just add two annotations, because Kubernetes could understand the annotations, and based on these annotations, they can poll the containers. Okay, still we have a problem. So the Prometheus knows that there should be an HTTP endpoint, but there is no HTTP endpoint. So the next is the flexibility. So until now, I said that we are just starting containers in the Kubernetes, but in fact, we are starting pods and not containers. So the pod is the Kubernetes unit for the container, and usually it's one container, but it also contains something like, for example, volumes. So one container, and I would like to mount a configuration file to the container. And in some strange cases, it could be multiple containers in the pod. This is the so-called sidecar pattern. So imagine that this is my Hadoop container, and you can add any additional container, and the strength of this approach that both of the containers can see the same network interface, can see the same volumes, and after Kubernetes 1.10 can see the same processes. So it's very easy to create something which just connects to the good old Java process and publish all of the metrics in a HTTP form to Prometheus. And this is what can we do, and it's just a few lines of bash code what we can add in a different container, and the only thing what we need is just add these 2 lines for the Kubernetes resource definition. So that's the flexibility that without modification, I just added a monitoring tool. And the same is true, for example, log collection. So you don't need to create an own log collection because plenty of log collections are already integrated with Kubernetes. Okay. So we have Kubernetes. Next question that, is Hadoop cloud native or not? Yeah. I think we saw that it's very easy to start the Hadoop, and it's very powerful. But there are some problems, but minor problems, because Hadoop is designed to be a distributed application, actually. So it's very easy to run in Kubernetes, but there are some areas which can be improved. For example, this DNS handling. It could be turned off, but it's very hard to turn off everywhere. And there is other things that the configuration loading could be improved to make it more dynamic, or yeah, the UIs, just as an example. This is the UI of the Ozone, and it could work over a reverse proxy. So it's very typical that in a cloud-native environment, you can see the UIs over a reverse proxy. And currently, the good old Hadoop UI, the name.ui, for example, doesn't work yet, but hopefully it will be fixed soon. Okay, so that was the one direction. So Hadoop could be started in Kubernetes, and it's very useful or very powerful to run in Kubernetes. But there is another direction. So what about Kubernetes? It's worse, or maybe we need just Kubernetes and we don't need Hadoop anymore, right? Well, the Hadoop is multiple subprojects, so Yarn, HDFS, and I think the storage part could be very useful in the Kubernetes part. So that was the picture of the Kubernetes, and we discussed that there are some additional services, for example, the storage. In fact, the storage layer is pluggable, so you can use multiple storage providers. And after that, you can see the same storage from each container. Okay, and we also discussed that with Hadoop Ozone, we have this low-level block layer, the data layer, where we have just bytes, which are replicated. And we can create additional layers, for example, this Quadra, which could publish the data over any kind of interface, for example, as an ext4 file system. Hadoop supports multiple storage, NFS, iSCSI, local storage, a lot of type of storage. What Quadra supports is the iSCSI interface. So over iSCSI, we can publish the available capacity to Kubernetes as well. Okay. How does it look like? This is, again, a Kubernetes resource definition. You don't need to understand all of the details, but something like this is a container definition here, and we are just running a cat command to wait for attaching volumes. And yeah, that's the important part. So I can say that I need some volume from a persistent volume claim. So the persistent volume claim is the important part. So I can say that, oh, it would be great if somebody would have a 1 gig storage. And yeah, there should be the connection between the claim and the pod. It's the name. But the important thing is that we need a persistent volume with the same size and the same type. So this is the exact persistent volume. And this is volume specific, so because it's an iSCSI volume, we need all of the iSCSI data, which is depends from our Ozone or Quadra cluster. Okay, but let's simplify it a little bit. So let's just say that we have a resource pod definition, we have this persistent volume claim, and the claim is bound to the persistent volume. Okay, there are two types of provisioning of the volumes. One is the static provisioning, where we have the volumes because they are created by the system administrator. And when a new pod requests a new persistent volume, it will be just bound to the persistent volume claim. The other one is the dynamic provisioning. So there is a new resource, and we need 1 gig storage, but there is no storage. But we have a component, which could be the Hadoop, which can create the volume dynamically, and the volume finally will be bound to the resource. So that's what can be done with the Hadoop, at least with this Quadra. So this is the good old Hadoop. This is the HDFS part. We have a master component, and we have the slave components. And every slave component, we can activate this new HDDS layer, which is just a plugin in the data node. So this is the master component of the new HDDS layer. This is about the binary replication. And this is the object store, which is similar to the S3. So here we have the mapping between the key name and binary. And this is the other system which provides the raw ext4 values over iSCSI for the nodes. And this is the dynamic provisioner which could check the Kubernetes API if somebody needs new storage and can just create new blob store here and just make it available for all the nodes. So this is how it works, but maybe it's more simple just to show, oh, okay, maybe it's easier to, I can see it because it's here. Okay, let's just do, so this is a Kubernetes UI, and yeah, there are a lot of details here, and maybe we don't need to understand all of the things, just the feeling, the how does it work. So we have a lot of components. We have all of the name node, data node, all of the servers running in separated containers. And the C block is the old name of the Quadra. This is the iSCSI part and the storage part. Okay, we registered this storage class. This is required where, oh, I have, where is it? Oh, just a moment. I would like to turn off the subtitles, subtrack. Okay. What has happened in the meantime? I lost it. Okay, so we have the components. We registered Hadoop as a storage class, so Hadoop will provide storage. Okay, what can we do? We can create a new resource. It's very similar to what we saw, that we have the persistent volume definition. Oh, it would be great if somebody had 1 gig storage. And we have the deployment, and there is the storage. Yeah, and there is the volume definition. And the claim name is the same, so I need a claim. And the claim defines that I would like to use 1 gig storage. Okay, let's upload it. And hopefully, we will have some storage. Okay, and now persistent volume claims, we can see that, oh, there is the claim, and it's bound. So we have a volume, but the volume is magically created by the Hadoop component. This is the persistent volume. Oh, okay, we have the persistent. You can see that it's this random number. So I'm pretty sure that it's not created by me because I can't type so long random numbers. Okay, and these are the raw data to access actually the Hadoop storage. Okay, but it takes some time to be started because we need to format 1 gig over the network. So in the meantime, we can just go to the console and go inside the newly created container and check if the C block is started. So this is inside the management service. And we can just see that, oh, really, they are created magically and without any intervention. Okay. So it's created. Maybe we can just make it more faster and go to, okay, because it's still formatting. Okay, let's go to here. Oh, finally it started. So we have the container. And it's running. Oh, yeah, we had some problem because it was too slow to format the whole volume. But because Kubernetes is smart enough, just try it again and again. After, I don't know, 4 minutes, we have the new volume. So we can go to the newly created container, which is not part of the Hadoop cluster. It could be any kind of container. And we can just check if it's mounted. Yeah, mounted, but not, yeah, that could be the good path. Yeah, there is a new empty storage. So I can just create a new file. I was here. Okay, the new file is there. So it's somewhere in the Hadoop cluster, but I can see it over the ext4 file system. Okay, mounts. Yeah, there should be a mount. There is the mount, the ext4 file system. Some magic by the Kubernetes itself. And what we can do is just delete the pod. Because as I mentioned, most of the resource definitions in Kubernetes just a rule that how the pod should be created or a container should be created. If I delete the container itself, it will be recreated automatically. And actually, it will be recreated on another machine. So this is one machine, one host name. This is another host name. So it's recreated on another machine. But even if it's recreated on the other machine, after a while, because again, it should be unmounted, synced, everything. So after a while, bang, reload. So now it works. And this is a container with the same settings, but started on another host. And on the other host, I can go to the container. This is a new container, actually, with the same settings. And the same storage is just mounted. So, my file is there. I'm happy. OK, so that's what we can achieve with the new Hadoop sub-projects. OK, stop. So let's go back to the presentation. But that's almost everything, what I can say. So that's the two parts, right? The Hadoop could be run in Kubernetes in a very powerful way. We will have out-of-the-box monitoring, logging, everything. And the Kubernetes could use the storage from the Hadoop HDFS cluster, or more precisely, this HDDS cluster. OK, so just a summary. The containerization, it's powerful, even if we use it just from local Docker Compose. But Hadoop can be started relatively easy in the cloud, in any cloud-native environment, but especially in Kubernetes. And it could work. We can improve the Hadoop with this DNS, and it could be even better. And the other side, that with the Hadoop cluster, we will have not just an HDFS storage or Hadoop compatible storage, but we will have an object store like S3, and we will have some raw storage which could be used from any other container. That's the vision, that Hadoop is all-in-one storage, or a Hadoop HDFS together with all of the new subcomponents could be just some all-in-one storage system. OK, that's pretty much all. I have some source here where I'm just containerizing the Hadoop and other big data, including Ozone. Is there any question? It's just because it's not yet finished. So sooner or later, we will have a separated page to introduce Ozone and put all of the existing documentation.
You mentioned efficiency. How did you compare those two approaches?
Which approaches?
The Hadoop in Kubernetes
and natively in a node.
Yes.
I think it's almost the same. So it's very low overhead to run something in the container. It's another question, the storage. So the efficiency of the storage. So it's not faster than the local SSD, right? So it's not for that. But it could be. There are some caches, and it's under development actually. So the first Ozone will be released midsummer, hopefully. So it's another question that the speed of the storage. And there are some use cases when the local storage is faster and more useful, but it won't be replicated. Yes. So if you don't replicate data, it will be a little bit slower, but it will be replicated. So that's the deal. But just to put container, it's no problem. So even just in this laptop, I started 24 containers or something like this. and 16 gig memory or something like this. Okay. Any other question?
All right, then, thank you.
Thank you very much.